And today we are talking about double and half angle identities. They are on the same formula handout sheet from yesterday. You don't have to memorize these formulas today. You get to have a formula sheet on the quiz tomorrow, as well as the test on Tuesday. Now this first section. Now for some reason all of yours have angle A, but on our handout all of these are theta. So if I say angle A or theta, they're the same thing, formula-wise. Now, this first section are called the double angle identities, and they are called double angles because notice all of these angles A or theta have been multiplied by 2. Now, notice that for cosine of 2A or cosine of 2 theta on your handout, there are 3 different formulas. So, if you have to find the cosine of 2A, you can pick which one of the 3 you want to use. Now, if all you have is the sine value, then you have to use the second formula. If the only thing you have is cosine, you would have to use the bottom formula. But if you know sine and cosine, you could use the first one, or you could use any of the 3. It doesn't matter. So just depending on what information you have. And in the second column, we have what's called the half angle identities. And on your handout, for the formulas, all of these were theta. So if I say angle A or theta, it means the same. And all 3 of these in the second column are called half angle identities because the angles have been cut in half. Now notice all 3 of these formulas for the half angle identities have the plus or minus out there. And in your final answer, you will only have one. It will either be, your answer will either be the positive square root or the negative square root. And that's going to be determined by which quadrant that angle terminates in. So if that angle terminates in quadrant 1, then the sine would be positive, the cosine would be positive, and the tangent would also be positive. Now if that angle terminates in quadrant 2, then the sine would be positive, the cosine would be negative, and the tangent would be negative, and et cetera, et cetera. So based on the terminating location, which quadrant does it terminate in, will determine whether you choose the positive answer or the negative answer. So let's get started by recognizing the formula. So the instructions say to simplify the given expression. So for number 1, we have 2 times the sine of 45 degrees times the cosine of 45 degrees. Now on your formula handout, this would be 2 sine of theta, cosine of theta. And that looks like which one of those formulas?
The first one.
That first one, sine of 2 theta. But they're not using theta. What are they using for theta? 45 degrees. So we need to do 2 times 45 degrees. So this is a double angle identity. It's being multiplied by 2. And simplify. So this can be simplified with 2 times 45 degrees. 90 degrees. Sine of 90 degrees. If it's a unit circle value, you need to continue one final step. So thinking about my unit circle, 90 degrees would be right here. What is that order pair? 0, 1, so what's the sine of 90 degrees?
1.
So if it's a unit circle value, keep going. Next one, number 2, we have 1 minus 2 sine squared of theta, and that looks like which formula?
The third one.
The third one for cosine of 2 theta. So this is cosine of 2 theta, but they didn't use theta. What did they use? 25. And 2 times 25 would be 50 degrees. So cosine of 50 degrees. Now 50 degrees, is that a unit circle value?
No.
No, so that is as far as we can go for number 2. But if it were a unit circle value, we keep going. Next one, number 3. Number 3, this would be 2 tangent theta over 1 minus tangent squared of theta. And that looks like which formula? The last one, tangent of 2 theta. But they're not using theta. What are they using for theta?
104.
104. So we need to do 2 times 104 degrees. And 2 times 104 degrees would be?
208.
208 degrees. Now, is 208 degrees a unit circle value? No. So we're going to stop right there. Number 4. We have 6 cosine squared x minus 3. Does that look like a formula? Let's see, this would be 6 cosine squared theta minus 3. But we don't have one with a 6 and a 3, but we have one that has what? 2 and 1. So that means the normal formula should have been 2 cosine squared theta minus 1. So what was this multiplied by to give us 6 cosine squared theta minus 3? 3. So 3 times 2 gives us 6 cosine squared theta. 3 times negative 1 gives us negative 3. So that formula was multiplied by 3. So this would be 3, and 2 cosine squared theta minus 1 is for what formula? Cosine of 2 theta. But they didn't use theta. What did they use?
X.
X. Now, can I do anything with the 2x unit circle-wise? No. No. So the answer is just 3 times the cosine of 2x. Next one, number 5, we have 8 sine x cosine x. Is that one of the formulas exactly?
Yes.
No, but what formula does it look like?
The first one.
It looks like that first one. It looks like 2 sine theta cosine theta, but that formula was multiplied by what? 4. So that formula has been multiplied by 4. So bring down the 4, and 2 sine theta cosine theta is for what formula? Sine of 2 theta. So this would be 4 times the sine of 2. And for theta, what are they using for theta? X. Now I put a parenthesis there. Did I have to have those parentheses? No. So this is just 4 sine of 2x. Number 6, we have sine of 3 theta, cosine of 3 theta. Does that match one of our formulas exactly? No, but which formula does it look like? Yeah, it looks like the formula that's 2 sine theta, cosine theta. But it was multiplied by something, because what number do we have out front? A 1. So it should have been a 2. So what was it multiplied by to make this become a 1? 1/2. So 1/2 times 2 gave us the 1. So this would be 1/2 sine of 2 theta. But they didn't use theta. What did they use? 3 theta. And 2 times 3 theta would be 6 theta. So 1/2 times sine of 6 theta. And the next one, I see the word tangent. And the tangent formula is 2 tangent theta over 1 minus tangent squared of theta. But does that formula match this one? No, this formula was multiplied by what? 2. So this would be 2 times the tangent of 2 theta. But they didn't use theta. What did they use for theta? 150 degrees. And what's 2 times 150 degrees? 300 degrees. Can I simplify that? Yes. What is the tangent? First of all, 300 degrees terminates in quadrant 4, so in quadrant 4, would the tangent be positive or negative?
Negative.
Negative. Sine is negative, cosine is positive, so the tangent would be negative. And the reference angle here would be 60 degrees, and what's the tangent of 60 degrees? Square root of 3. So this would be negative square root of 3. And when I multiply that, that's negative 2 square root of 3. And the next one, if you have a square root, that's going to be one of those half angle identities. And this is the half angle identity for sine, cosine, or tangent. Cosine. Notice we have a 1 plus cosine. So that's going to be cosine of theta over 2. So cosine of half of theta. So if they didn't use theta, what angle did they use? 60 degrees. And half of 60 degrees would be 30 degrees. And we know the cosine of 30 degrees is square root of 3 over 2. Next one, we have 1 minus cosine pi over 8. Again, if you see a square root, it's going to be a half angle identity. And it's just a half angle identity for sine, cosine, or tangent. Sine, so this would be sine of half of theta. But they didn't use theta, what did they use? Pi over 8 needs to be cut in half. And instead of dividing by 2, I could multiply by 1/2, and pi over 8 times 1/2 would be pi over 16. So this is just sine of pi over 16. That is not a unit circle value, so we'll leave it as just sine of pi over 16. And the last one in this section, again, you see a square root, so that means it's going to be one of the half angle identities. And this is the half angle identity for which one? Tangent. So this would be tangent of half of theta. And for theta, they use 120 degrees. And half of 120 degrees is
60.
60 degrees. And the tangent of 60 degrees is
Square root of 3.
square root of 3. Now notice up here we have the plus or minus, but we know 60 degrees is in which quadrant? So in quadrant 1, your answer for tangent would be positive. So again, even though we have the plus or minus, you will only have one in your final answer, either positive or negative, based on the terminating quadrant. Okay, the next section, now we're going to use the half angle identity to find the exact value. So number 11, we have the sine of 165 degrees. And 165 degrees is half of what angle?
330.
330? So half of 330 degrees gives us 165. Okay, so using that identity. So again, the half angle identity, we're going to start with a plus or minus. So only the first step will have a plus or minus. Now for the numerator, we're going to have 1 minus cosine theta. So 1 minus cosine of theta is 330 degrees. And in the denominator of the formula, we'll have a 2. So 1 minus cosine theta, 2 in the denominator. Now the first thing we'll have to decide, will our answer be positive or negative? So we are looking at this original angle. 165 degrees terminates in which quadrant? 2, and in quadrant 2, would the sign be positive or negative? Positive. So I'm going to circle the positive so I remember my answer is positive. So I'm not gonna use the plus or minus anymore. The answer is positive. You don't have to put a plus sign. Now fill in the information. So 1 minus, what is the cosine of 330?
110.
What's the reference angle? 30 degrees. And what is the cosine of 30 degrees?
Square root of 3 over 2.
Square root of 3 over 2. And if we're in quadrant 4, would cosine be positive or negative? Positive. So this would be 1 minus positive square root of 3 over 2. And in the denominator, we'll have a 2. Now, the rule today is we do not want to leave a fraction inside of a fraction. We don't want to leave a complex fraction. So we need to go ahead and clear out the denominator. So to clear out the denominator, what would we have to multiply by? 2. So we are going to multiply the numerator by 2. Whatever you do to the numerator, you also have to do to the denominator, because 2 over 2 is equal to 1, which doesn't change the equivalency of that fraction. So distribute the 2. 2 times 1 is?
2.
2. We'll have the minus sign. What happens right here?
You get square root of 3.
These 2's cancel, right? And this is just 2 minus square root of 3. Then in the denominator, 2 times 2 is?
1.
4. So that's the first thing you need to do, clear out the fraction. Multiply the top by 2, multiply the bottom by 2. Now the next thing you need to do is when you square root a fraction, you actually are taking the square root of the numerator as well as the square root of the denominator. Now I'm not going to try to figure out what the square root of 2 minus square root of 3. I'm just going to leave the numerator alone. But if the denominator is a perfect square, simplify that one. And what's the square root of 4? 2. And that's the final answer. We'll leave our answer like that. So make sure your final answer, you don't have a perfect square in the denominator for a square root. And make sure you don't leave a fraction inside of a fraction. Next one, tangent of 105 degrees. 105 degrees is half of what angle? 210. So we need to do tangent of half of 210. So again, with the half angle identity, the first step will have the plus or minus. That is the only step that has the plus or minus. And the formula for tangent, for the half angle identity for tangent, is 1 minus cosine theta. So this would be 1 minus cosine of 210 degrees. And the denominator is 1 plus cosine of 210 degrees. Now I have to decide, is my final answer going to be positive or negative? So look at your original angle. 105 degrees terminates in which quadrant? 2, and quadrant 2, would tangent be positive or negative? Negative. So circle the negative. Now from here forward, I'm not going to have the plus or minus. I'm just going to have the negative. And we'll have 1 minus cosine of 210. 210 degrees is in which quadrant?
3.
3, and in quadrant 3, would the cosine be positive or negative? Negative. And what's the reference angle for 210 degrees?
1/2.
30, and cosine of 30 is?
1/2. Oh, shoot.
Square root of 3 over 2. So in the denominator, this would be 1 plus negative square root of 3 over 2. Whoops, went down too far. I'm going to clean this up a little bit. So this would be 1 plus square root of 3 over 2. And this will be 1 minus square root of 3 over 2. Now, the next thing I need to do is clear out the fraction. And to clear out the fractions, what would I have to multiply by? 2. So whatever you multiply the top by, you also have to do to the bottom. So whatever you do to the top, do to the bottom. So that gives us 2 plus square root of 3 over 2 minus square root of 3. Now, do I have a perfect square in the denominator? No. So that's as simplified as I'm going to get it. Next one, 13. 157.5 degrees is half of what angle?
240.
315.
315 degrees. So our half angle identity, again, only the first step will have the plus or minus. And for the cosine half angle identity, it's 1 plus cosine theta, so this would be 1 plus cosine of 315 degrees, and a 2 in the denominator. Now we'll have to decide, will our answer be positive or negative? So looking at our angle here, 157.5 degrees, termination with quadrant. 2 and quadrant 2 would cosine be positive or negative? Negative. So I'm going to circle the negative, and from here forward, bring down only the negative. And this would be 1 plus 315 degrees, termination with quadrant. 4 and quadrant 4 would cosine be positive or negative? Positive. And with the cosine for 315 degrees? Square root of 2 over 2. Clear out the fraction. And to clear out the fraction, what do we have to multiply the top and bottom by? 2. So multiply the top by 2, multiply the bottom by 2. So whatever you do to the top, you have to do to the bottom. So when I distribute the 2, that gives me 2 plus square root of 2. And in the denominator, 2 times 2 is 4. Can I leave my answer like that? No, I cannot leave a perfect square in the denominator. So square root the numerator. And when you square root the denominator, square root of 4 is 2. So do not leave a perfect square in the denominator of a square root. Okay, diagram time. Now it says to use double angle identities to solve, and we have cosine of theta is equal to square root of 5 over 5 with theta in quadrant 4. So step 1, draw yourself a diagram. And angle theta is in quadrant 4. And they gave us cosine this time, which is adjacent over hypotenuse. So the adjacent side is square root of 5. The hypotenuse is 5. This one we'll have to actually use Pythagorean theorem to find the missing side. So a squared plus b squared equals c squared. So square root of 5 squared plus b squared equals 5 squared. And what is square root of 5 squared?
5.
5 plus b squared equals 5 squared is 25, and 25 minus 5 is 20. And when I square root of 20, simplify that radical, and square root of 20 is equal to 4 square root of 5, 2 square root of 5. And since this is below the x-axis, this would be negative 2 square root of 5. So, now we're ready. So, sine of 2 theta, straight off the formula chart. Sine of 2 theta, that formula is 2 sine theta cosine theta. So this equals 2 sine of theta cosine of theta. So this will be 2. And sine of theta, opposite over hypotenuse would be? Negative 2 square root of 5 over 5. Cosine, they gave us the cosine. They said cosine was square root of 5 over 5. And multiply those 3 together. And if you want to, you can make that 2 over 1. So multiply these 3 with 2 times negative 2. Negative 4. And what's square root of 5 times square root of 5? 5. So negative 4 times 5 gives me negative 20. And in the denominator, 1 times 5 times 5 is 25. Should I leave my answer like that? No, simplify. Negative 20 over 25 simplifies to?
Negative 4 thirds.
Negative 4 fifths. And number 15, cosine of 2 theta. Now this one, we have 3 formulas. We could do any of those 3. Which ones do we want to do? First, second, or third?
First.
First. So cosine squared theta minus sine squared theta. It doesn't matter which one you choose, you'll get the same answer in the end. So what do we put for cosine? Square root of 5 over 5, and that cosine needs to be squared. And what do I put for sine? Negative 2 square root of 5 over 5, and that also needs to be squared. So square root of 5 squared gives you 5 over 25. Minus, we square the numerator, what does that give us here? Let's see, the 2 gets squared and it's
Negative 20 over 25?
it would be 20 over 25. When you square a negative, this becomes positive. So we're subtracting a positive 20 over 25. And 5 minus 20, negative 15 over 25. And that simplifies to negative 3 fifths. And the last one for the double angles, before we move on to the half angles, this time we went tangent of 2 theta, and tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So looking at our triangle, tangent is opposite over adjacent. So negative 2 square root of 5 over square root of 5 is negative 2. And in the denominator, this will be 1 minus negative 2 squared. And 2 times negative 2?
Negative 4.
Negative 4. When I square the negative 2, this becomes positive 4, and 1 minus 4?
Negative 3.
Negative 3, and that fraction simplifies to
4 thirds.
4 thirds. Okay, the last 2, now we are moving on to some half angle identities. First thing we need to do is draw ourselves a diagram, and it says angle A is in quadrant 3. And they gave a sign which would be opposite over hypotenuse. Now which side should be negative? The opposite side or the hypotenuse? The opposite side. Hypotenuse is always positive, so your hypotenuse needs to be positive 5. The opposite side is negative 4. And knowing your Pythagorean triple, the adjacent side would be
2.
not 3.
Negative 3.
Negative 3. Why is it negative 3?
Because that would be negative.
It's on the left side of 0. Okay, so the first one, cosine of A over 2. That formula is going to be plus or minus square root 1 plus cosine of angle A over 2. Now, we have to decide, should cosine for angle A over 2 be positive or negative? Did they tell us which quadrant angle A over 2 is located? We know angle A is in quadrant 3, but what about half of A? Do we know where it terminates? No, but we can figure it out, because we know that angle A is between, this would be 180 degrees, this would be 270 degrees. So we are given angle A is between 180 and 270. But we don't want angle A, we want the original. So we're given A over 2. So if I divide angle A by 2, these quadrant boundaries also need to be cut in half. So half of 180 would be 90 degrees for angle A over 2, so it would be between 90 degrees and what? 135 degrees. So angle A over 2 is in what quadrant? Quadrant 2. So for this first one, if the cosine in quadrant 2, should I take positive or negative? Negative. So this one is going to be negative. A over 2 is in quadrant 2, and in quadrant 2 the cosine is negative. So this is going to be negative square root 1 plus, what's the cosine of angle A? Negative 3/5, so instead of 1 plus negative 3/5, I'm going to write this as 1 minus 3/5. And in the denominator we will have a 2. Now, instead of 1, I'm just going to think of this as 5/5. So what is 5/5 minus 3/5? 2/5. Needs to be cut in half. And what's half of 2/5? Half of 2/5 would be 1/5. And the last one, we want the tangent of A over 2. The tangent of half of A. And off of that formula is going to be plus or minus the square root. And in the numerator we have 1 minus cosine A 1 plus cosine A. Now we have to decide whether A should be positive or negative. Which quadrant do we say A over 2 is located? Quadrant 2, so in quadrant 2, would tangent be positive or negative? Negative. So it brings up the negative. We'll have our square root. 1 minus, what's the cosine of A? Negative 3/5, so when I subtract the negative, this changes to positive 3/5. And this would be 1 plus negative 3/5 would be 1 minus 3/5. Now instead of 1, I'm thinking of this as 5 over 5. So 5/5 plus 3/5 would be 8/5. And 5/5 minus 3/5 would be 2/5. And when you divide fractions, multiply by that reciprocal. So we need to multiply 8/5 by the reciprocal, which would be 5 over 2. And that would be 8 over 2, which is